Let us calculate the potential evapotranspiration from an area in North India in the month of November by Penman's formula. Latitude 30° north. So it is located somewhere in this region. Elevation 220 meters above mean sea level. Mean monthly temperature is given. Relative humidity, observed sunshine hours, wind velocity at 2-meter height, nature of surface cover, loose growing green crop. So we'll calculate potential evapotranspiration using Penman's formula. So the notations are given here. First, we will need to calculate A. A is the slope of saturation vapor pressure versus temperature curve at mean air temperature in mm of mercury per degree Celsius. A is obtained from the standard table. Slope of EW versus T curve. This is A for temperature 20 degrees Celsius. It is 1.05. EW is 17.54. It can also be calculated using this formula 4.54 exponential 17.27 into temperature 20 degrees divided by 237.3 plus T. So if we use this equation, we'll get the same value. HA, mm of water per day, it is also obtained from this table. HA for 30° north latitude and November month, the value is 9.1. HA. HA is the incident solar radiation outside the atmosphere on a horizontal surface expressed in mm of evaporable water per day. It's a function of latitude and period of the year. So we have obtained it from the table. N is also available from the table. N 30° latitude, November month, it is 10. And small n is already given. Actual duration of bright sunshine hours. The mean value is given. Mean observed sunshine hours 9. So n divided by n 0.90. EA. EA is the actual vapor pressure. Now actual vapor pressure divided by saturation vapor pressure is equal to relative humidity. EA by EW is equal to relative humidity. So EA can be obtained by multiplying relative humidity with, this is the relative humidity, multiplied by saturation vapor pressure. So this is the value of EA. Now we'll be obtaining all these constants. A, small a, constant depending upon the latitude, and is given by A is equal to 0.29 cos phi. Now latitude is 30°. So we'll use this equation 0.29 into cos B4. B4 is the latitude, 30. This is B4. And we have multiplied it by pi divided by 180 to convert it into degrees to obtain the value of A. So 0.29 into cos B4 into pi by 180. So it will give us the value of A. The value of B is already given. It's a constant with an average value of 0.52. 0.52. Stephen-Boltzmann constant 2.01 into 10 raised to minus 9 mm per day. Now the value of TA. TA is 273 plus degrees Celsius. So 273 plus Celsius. So value of TA is obtained. Now 2.01 10 raised to minus 9 multiplied by 293 raised to 4. 1.48 into 10 raised to 1. The value of albedo for close green crop is 0.25. So now we will be using all these values to calculate HN. HN is the net radiation in mm of evaporable water per day. We have obtained all these values. So HN can be obtained using the same equation. This is the same equation. The value is 1.857 mm of water per day. Now we will calculate EA. EA is the parameter including wind velocity and saturation deficit. 0.351 plus U2 by 160. U2 is the wind velocity at 2 meter height. It is given 80 kilometers per day into EW minus EA, saturation vapor pressure minus actual vapor pressure. So 1 plus B9, which is 80 kilometers per day by 60. The formula is already written here. So 2.302 mm per day, and potential evapotranspiration will be obtained using this equation, Penman's formula. AHN plus EA, all these values are obtained. The psychrometric constant is given 0.49 mm of mercury per degree Celsius. So we'll be using the same formula. So using this formula, we'll obtain the potential evapotranspiration as 2.066 mm per day. This is the final answer. Potential evapotranspiration is equal to 2.066 mm per day.